manifest hari ni, but since there are some requests kan from students, ada tidak air lah contoh. So kita buat online lah. Okay, so today kita akan discuss on aggregates lah, but I believe all of you know what is aggregates already lah, just macam revision lah kan in topic. Okay, so why aggregate is important in concrete? So there are 3 reasons given here lah. One, because of the aggregates, it will give body to the concrete, because we know that aggregates actually there are 2 types. There are coarse aggregate and also there are fine aggregates. So normally the coarse aggregate ni akan give body to concrete lah because of their larger size. And the second one, reduce shrinkage, because we know that concrete, when it is exposed to environment, sometimes it can shrink lah. So this coarse aggregate, this aggregates actually help to reduce shrinkage of the concrete. And the third reason why aggregate is important, because of the economy. Because if you compare the coarse aggregate with cement, for example, so coarse aggregate is much cheaper lah. Okay, so they reduce bagi benefit in terms of the economy juga. Aggregates, it will occupy about 70 to 80% lah of the volume of concrete lah. So kalau kita tengok 7 to 80 is quite large kan, the amount. So the effect of aggregate in concrete also, the influence of aggregate in concrete also is very significant. Okay, and then in concrete, this aggregate, they can be considered under 2 phase material. Number 1 is the paste. So paste here referring to the cement paste lah. So fasa cement paste. The second one is the aggregate punya fasa lah. So paste and aggregate phase. So these are the properties that we are going to look this topic. Okay, so the classification, the source of aggregate until the grading. Actually, not until the grading. Dia ada lagi bawah ni segregation. Okay, so first we look at the classification of aggregates. Classification of aggregate, actually there are several types of classification lah. But here in this concrete technology, we will consider, I think there are about 3 classification of aggregates lah. Okay, number 1 is classification of the aggregates based on the density. So meaning that kita boleh kelaskan aggregate based on the density lah. So ini based on its wet density. Okay, so number 1, aggregate can be classified as normal wet aggregate. So this is normal wet aggregate is the type of aggregate that is normally used in the general construction. And the second one is the lightweight aggregate. So lightweight aggregate. Okay, so this one is the lightweight aggregate. Normally we use this lightweight aggregate to produce lightweight concrete. The last type is heavyweight aggregate lah. So not only lightweight, but we also have this heavyweight aggregate. So heavyweight aggregate, normally if you want to produce heavyweight concrete lah, let's say for radiation shielding and so on. Okay. Okay. So normal wet aggregate. So we look in detail on the first type of aggregate classified under yang density lah, normal wet aggregate. So any types of natural aggregate such as sand, gravel, crushed rock. So crushed rock ni can be granite, sandstone, basalt and so on. There are many types. Actually they are considered under the normal wet aggregate lah. Even the artificial aggregate like brick, broken brick, air-cooled slag, okay, also considered as artificial. So natural ni yang kita dapat natural lah, dari sumber yang semula jadi. Artificial, this is a man-made aggregate lah. Okay, so we also have artificial aggregate fall under this normal wet aggregate. And then so this is the table. It shows the category, the density of the aggregate, the concrete. Tapi dia punya susunan tak berapa betul ni. Nanti kamu kasih betul sajalah. Okay, so first category is the ultra lightweight. So ultra lightweight aggregate. This one, the aggregate used is the meter. So kalau let's say you want to produce concrete and then you use aggregate which has density less than 500 kilogram per cubic meter, then this you able to produce lightweight concrete lah, ultra lightweight concrete. So ultra lightweight concrete where the concrete density or unit weight of the concrete is between 300 to 1,100 kilogram per cubic meter. But the ultra lightweight concrete, normally we don't use it for structural lah. So the typical application is for non-structural. And then the strength pun is very low lah, less than 7 Newton per millimeter square or less than 7 megapascal MPa. For lightweight, okay, for lightweight concrete, this one it will use aggregate having density between 500 to 800 kilogram per cubic meter. So kalau berat aggregate is 500 to 800, then you can produce concrete with density 1,100 to 1,600 kilogram per cubic meter. But also one of the trend lah, if you reduce the density of your aggregate, normally kan the strength also will reduce. So that's why if you check here the ultra lightweight and lightweight, you can see that the strength too they are very low lah, less than 7 or between 7 to 14. Normally, if you want to use concrete for structural application, kita guna 30 and above lah, macam tu. Okay, structural application meaning that untuk tiang, untuk beam, mana-mana yang dia carry loading. Okay. And then for structural lightweight, this one is structural, so meaning that it will carry loading lah. Kalau structural, still lightweight, tapi you consider as a structural, the density of the aggregate is 1,100 to 1,750 kilogram per cubic meter. Then, tapi this one is silap, sorry, 650 to 1,100 kilogram per cubic meter. Okay, this is for structural lightweight lah. Okay, so the concrete you can produce is 1450 to 1900. For normal concrete, biasanya yang you produce untuk general construction, the density is 2400 kilogram per cubic meter. So if you refer to this table, okay, they still consider as lightweight concrete if the punya density is below 1900 lah, so still consider as lightweight. But for structural lightweight, if you see here the strength, there's 17 to 35 MPa, so minimum is 17 lah to be categorized as structural, as structural to carry loading lah. Okay, so this one for example application in masonry unit lah, structure. So the rest you can see lah, normal weight aggregate, kalau normal weight concrete 1100 to 1570, so they akan produce the normal weight concrete lah, 2100 to 2550, normally 24 lah, 2400. Okay, and then the last one is the heavyweight. If you want to produce heavyweight concrete, this one you have to use an aggregate with density more than 2100 kilogram per cubic meter. So with this heavyweight aggregate, then the type of concrete produced also the density is very high lah, 2900 until 6100 kilogram per cubic meter. So that's quite high lah. Okay, but the strength here for both normal and heavyweight, it can be within the range of 20 to 40. Actually can be more lah. Okay, can be more. Kalau boleh design, can be more is okay lah. Within the, tengok lah what is your range of density. But for heavyweight concrete, kalau you refer here, one of the application is for radiation shielding. Okay, sometimes mungkin for kalau you involved in the construction of macam prison, for example apa semua kan, so can be considered lah. Okay, heavyweight structure. Okay, so that is about aggregate, which is categorized under density. So aggregate also can be categorized based on size. This is actually the normal classification we use like in concreting work like in concrete technology. We base on the size normally. Okay, so if we categorize the aggregate based on size, so there are the dua. Okay, there are the dua. One is the cost aggregate. The second one is fine aggregate. Okay, so you categorize based on size only the cost aggregate and fine aggregate ni yang biasa kita guna. If the aggregate is categorized as cost aggregate, then you have to check the size. Size more than 4.75 mm, you can categorize it as cost aggregate. If less than 4.7 mm, then this one we categorize as fine aggregate. So any example of fine aggregate is sand lah, pasir. Okay, so for cost aggregate, this one is crushed stone lah, example lah, ni contoh. Okay. Okay, so aggregate also can be classified based on source. So this one I believe all of you already know lah because you already learn in I think in detail lah kan ya mana tu civil engineering geology, civil engineering geology. So if you categorize or classify the aggregates based on source, then there are three types of aggregates lah: the igneous, sedimentary, and also the metamorphic. So igneous, okay, the igneous rock, this one also can be used in concrete making. In terms of the properties, it is hard, tough, and dense, but sometimes it can be acidic, depends on the percentage of silica. If the amount of silica is high, then the possibility of the igneous rock to become acidic is high. Okay, and also it is reactive. Bila dia reactive, then the aggregate tend to react with the alkalis in cement. This one is kalau saya mau cerita one of our problem here in Sabah. We use sandstone aggregate because most of the quarries in Sabah are producing sandstone aggregate. So when we do research on this sandstone aggregate, we found that sandstone is reactive. So tapi dia tak semestinya under igneous lah. Itu you have to refer back to the engineering geology. So reactive aggregate actually one of the reason lah one of the reason of this damage or deterioration, which we call it as alkali silica reaction or alkali aggregate reaction. So alkali is from the cement, silica is from the aggregate, alkali aggregate reaction, and also it need water. So dia ada tiga factor. Dia kena ada reactive aggregate, alkali from the cement and water, then it will cause the alkali silica reaction. So kalau ada alkali silica reaction, your concrete will cracking. So it will damage your building lah. That is one of the problem. And then sedimentary rock. Okay, sedimentary rock, this is a type of rock which is produced after dia undergo weathering process. Dia kena tiup angin, dia kena aliran sungai apa semua kan, dia bergerak. So it normally sedimentary rock, the shape is smooth lah, dia macam bulat-bulat because of this weathering process. Okay, and also dia punya properties they vary from soft to hard, porous to dense, light to heavy. So dia berbagai lah. Okay, for example is limestone, but still can be used to produce concrete lah. Okay, and then the last type is metamorphic. Metamorphic is actually either igneous or sedimentary rock lah. Any two types of rock subjected to high temperature and pressure. So after this rock have been subjected to very high temperature and also pressure, then dia akan berubah in terms of the texture, in terms of the structure, in terms of the chemical composition. Okay, so for example here is quartzite and gneiss. So saya tunjuklah gambar dia. This one. Okay. It's all about classification of aggregate. So we can classify the aggregate based on three. Either you classify it based on the density, apa tadi tu, normal wet, light wet, and heavy wet. Or you can classify it based on the size. If based on size ni yang biasa kita buat, coarse aggregate and fine aggregate. And the last one, classification based on the origin lah. Okay, based on the source. Okay, igneous, sedimentary, and metamorphic. Okay, does the aggregate size matter? Adakah penting? Kenapa penting dalam concrete production? Okay, does this aggregate size matter? Okay, so if you refer from these three pictures, you can see that the texture lah, the physical, the texture of this aggregate, they are not similar lah, dia tidak sama sangat. For example, the first picture, that one crushed limestone, tapi ada limestone B, yang the last picture crushed limestone A. Okay, so this crushed limestone B, if you see here, the shape is cubic shape lah. Okay, and then their shape, size, texture. So the size here, the texture also, it is a shape also, still shape, cubic shape, medium angular. Okay, and low texture. What does it mean with low texture? Okay, kalau tengok low texture, texture is dia punya surface of the aggregate lah. If you can see, kalau dia smooth, maksud dia low texture. If dia punya permukaan tu kasar, high texture lah, or medium texture. So crushed limestone B, you can see it is cubic, medium, angular. Dia punya size, shape is angular, but the texture is low. Okay, you refer to the second picture. That one is the crushed gravel. But this one also is not macam yang crushed gravel produced in the factory ya. Ini macam dia after the weathering effect, because if you see, the punya surface is macam smooth. Okay, so that's why there are the low texture here. Okay, there angular lah. Okay, and this one, the punya shape is slightly flat, not betul-betul bulat. Okay, and the last picture one is crushed limestone A. Okay, so if you see the last picture, the shape is flat, dia macam flat, not cubic, they're flat or not round. Okay, and also the angular lah, angular, dia tajam-tajam macam tu. And but the texture here is medium, so meaning that the surface is rough lah, but not very rough. So they're categorized as medium texture. Okay, so this one is actually more on the shape and texture lah. Okay, but how about the size? Okay, does the size of aggregate matter? Macam mana? How aggregate size affect the concrete properties? Okay, this one is the concept that you must understand. If you use largest possible maximum aggregate size in your concrete production, so it will reduce. Number one is the cement content. Yeah, of course, because the largest bigger cost aggregate, the biggest size cost aggregate, of course, the specific surface area is dia apa? Okay, if your aggregate is large, kan? Large. So the surface area is high lah, low lah kan? The specific surface area is low. So meaning that you need less amount of cement to cover the surface area of the aggregate compared to the small cost aggregate. Ialah small aggregate lah. Okay, small aggregate, it has high SSA. Okay, so we need high amount of cement to cover all the aggregate surface particles. Okay, and also the same concept with the cement content lah. If the aggregate used in your concrete is large, then the water required to wet the surface of the coarse aggregate, the fine aggregate, it will be lower lah. Okay, selagi dia besar, cement content lagi kurang, and then the water required to wet the surface untuk basahkan permukaan also kurang. Okay, and also it can reduce the drying shrinkage. Okay, so does it mean that we can use sebesar size aggregate yang boleh in your concrete production? Macam mana tu? Okay, so bila kita kasih besar size, cement content kurang, so kita can reduce the cost konon lah, and then we can reduce the water requirement and also shrinkage. Tapi adakah boleh untuk semua keadaan? Okay, okay. So the maximum, the answer for that question, you refer to the second statement tu lah. The maximum size of aggregate that you can use in your concrete production, in your concrete, on your project lah, building project, okay, or any infrastructure project, it may be limited by these following conditions. One, you have to check thickness of the section. Let's say the thickness of your section, katalah tebal kamu punya lantai lah, tebal lantai tu katalah 50 mm, tiba-tiba 50 mm. So kamu mau pakai yang lagi besar size of aggregate, I want to use 60. So what happened to your mix? Kan 50 mm, then aggregate size is 60, then dia tidak sesuai. Should be less than the minimum section of your building lah, your structure. Dia kena lagi kecil. Spacing of reinforcement. So because we know that in our concrete, okay, in our concrete structure, in our structure, of course there is for reinforced concrete, dia ada rebar. And this rebar, when you do design, kamu akan setkan dia berapa size or design of rebar, dia punya distance kan in your concrete. Ada size, ada ni distance semua tu kena tahu. Okay, let's say the spacing of your rebar is katalah is katalah 30 lah. Okay, so spacing of your rebar is 30. Tapi kamu guna aggregate size is 50, then tidak boleh lah. Okay, nanti dia menyangkut di atas sini. Okay, pun tidak boleh. So should be less than the spacing of your rebar lah. Okay, and then also the clear cover. What is cover? Apa di cover in concrete? Concrete cover lah. Apa dia concrete cover? Kita padam dulu. What is concrete cover? Kita dah faham lah what is concrete cover. Okay, okay, concrete cover. Let's say this is your concrete lah. This is your cross section of your concrete lah. Cross section of concrete. Normally, you will have steel bar kan. You will have steel bar. So this is your steel bar. Okay, steel bar in your concrete lah. Okay. So the distance, katalah begini ya. The distance from the of the rebar, surface of rebar, macam tidak berapa clear. Surface of rebar, this is what we call as cover. Okay, the distance from the surface of concrete to the surface of your rebar, that is so it depends on the size of cover lah. Let's say your size, the size of your cover here is 25 mm, for example. So normally, size of your aggregate should be lower than 25 mm lah, tidak boleh besar. Okay, kalau besar nanti dia menyangkut di atas. Okay, and also the maximum size that you need to use lah in your concreting work, it also depends on mixing, handling, and placing technique. Okay, so this one we will discuss in detail in different topic nanti. Okay, so this is so the largest maximum actually it give you benefit, but still they akan limited based on this 4 condition. So the best is not actually the largest lah. The condition of your structure. Okay, and then for heavily reinforced concrete member. So what does it mean with heavily reinforced concrete member? Apa dia tu? Okay, heavily reinforced concrete member maksudnya in your concrete tu, your concrete structure, your concrete member tu dia ada banyak steel. Dia banyak steel. So that's why they call it as heavily reinforced concrete member. For in this condition, the maximum size of aggregate, it is limited or restricted to 5 mm less than the minimum cover to RC, to the concrete lah, whichever is smaller. Maksud dia, let's say if your concrete cover, macam saya beritahu tadi, is kata 25 mm, so the size of aggregate minus 5, dia kena less than apa? 5 mm less, so the size of maximum size, the maximum size of your aggregate in concrete is 20 mm. Okay, so if let's say 30, then the maximum size minus 5 is 25. But normally in construction kan memang kita guna 20 lah. From practical consideration, for RC work, we use maximum size of 20. This memang sudah memadai, satisfactory. Okay. How about shape? Tadi tu dia cerita pasal apa tu? Size. Okay, how about shape? How shape is important in concrete production. Macam mana? Okay, so if you refer this slide, dia dah bagi jawapan. The importance of shape, aggregate shape, because it will affect the workability. But how it affect the workability? I believe all of you already know what is workability kan? In our first lecture, I already show you what are the difference between the low workability and then high workability. Kalau low workability tu dia macam pekat lah, susah kita mau mix, susah mau tuang kan, susah mau compact. But then for high workability, meaning that the concrete floor is good, easy for you to transport, easy for you to place tuang, this tuang di dalam mall, and then easy for you to compact. So that is good workability. So the shape of aggregate, it affect concrete production by affecting the workability of your concrete lah, workability of concrete. So kita tengok, number one is round aggregate. Okay, number one is rounded aggregate. So dia bulat-bulat lah. Normally for round aggregate, the texture is smooth. Okay, bila sebut texture, you have to understand lah. Texture meaning that dia punya permukaan tu lah smooth, maksud dia licin. If the texture is smooth, surface is smooth, then less amount of cement is required. So yang economy tu because of cement mahal lah. Okay, not only it will cost less cement requirement, but also the amount of water to wet this round aggregate also will be less. Air dia pun jadi kurang. Okay, so kita tengok the next shape is angular aggregate. This one is tata number 2 lah. So angular aggregate macam yang kamu tengok dalam this one picture. So you can see that the aggregate shape is angular, dia tajam-tajam, and also the texture is rough. So dia ibarat macam ni lah, bergigi-gigi. Okay. So for angular aggregate which has rough texture, normally it has high surface area. So if it has high surface area, high SSA, so it needs more water. It needs more water, and also it needs more cement to wet or cover all this dia punya permukaan. However, even though it requires more water and you need more cement to wrap or cover the surface of this rough texture angular aggregate, but in terms of dia punya performance of the concrete, especially the bonding here, the bonding is very good. Sebab dia bergigi-gigi kan, so it will produce a good mechanical interlocking effect to the aggregate and to the cement paste. So dia bagus lah. So giginya bagus, dia lock, then bond also will increase. So as a result, the concrete produce also will have good strength, okay, and also will have good durability. So dia ada limitation and dia ada benefit lah. Okay, so if you refer to the previous one, this one rounded aggregate, yes, it will require less amount of water and less amount of cement. So kurang sikit duit lah. But then in terms of the mechanical keying effect between the cement paste and this aggregate, normally their bonding is low. So if the bonding is low, then the strength and durability of the concrete produce also will be lower. That is how shape affect the aggregate, the concrete properties. Okay, so workability dah faham kan? Round aggregate, it will increase the workability. It will increase the. Given that, let's say you have two types, you want to produce two types of cement, but the punya water, the amount of water is similar lah. Concrete A and concrete B. So concrete A is using rounded aggregate with smooth texture. Concrete B is using angular aggregate with rough texture. So concrete A, it will require katalah air sama kan. So concrete A, it will have higher or lower workability. Katalah this one, concrete A, they use round aggregate, round and smooth lah aggregate. And then you have another concrete B, they use angular or crush aggregate lah, angular crush aggregate, aggregate. So katalah water content this one is 10 kg. This one also 10 kg. So which one will give higher workability, A or B? Tolong jawab.
B.
B atau A?
A.
A. Kenapa?
Surface.
Apa dia?
Shape and surface.
Dia sebab dia itulah kalau soalan dalam ujian kata tanya saya buat soalan begini, kamu kena jawab dan kamu kena justify. Jawapan dah betul. Memang A same water content A 10 kg water, B 10 kg water, but the different only satu round aggregate, satu angular crush aggregate lah. So jawapan kawan tadi dah betul. Memang A will have high workability lah. Why? Because justify dia. Dia bagi reason. Because the aggregate in yang aggregate it has smooth surface. Okay, so bila the smooth surface, less amount of water is required to wet the aggregate surface. Less amount of cement, water. Tapi kita cakap pasal workability, then less amount of water lah compared to angular. Dapatlah markah. Okay, so hopefully yang lain faham lah. Okay. Okay. Are polished, smooth or rough. Okay, that depends on the particle surfaces lah. Sometimes they're rough but not very rough. It depends on the degree lah. Kalau dia terlampau teruk, terlampau tinggi roughness, so the degree of dia punya roughness is high lah. The dull, smooth or rough. So that is texture. Okay, because how this texture affect the concrete properties, if you refer to the second one lah, as the surface smoothness increase, makin licin, so the contact area decrease. Satu licin, satu kasar macam ni. So this one, semakin dia licin, so the contact area between the aggregate and the cement paste, CP saya letak cement paste lah. Cement paste dia akan reduce the contact area. This one kalau dia smooth, if the texture is kasar, then the aggregate, the surface area, the contact surface area will be high lah. So if the contact area decreases, the contact area between the cement paste and aggregate is decreases, so the bonding also will low lah compared to yang kasar tadi. Okay, so that is how the texture of aggregate affect concrete properties. Okay, in terms of strength, okay, the strength of parent rock does not exactly indicate strength of aggregate. So what does it mean? Maksud dia, aggregate ni before you use it in concrete or in any application, memang dia asal daripada batu kan, batu di bukit-bukit, di mana-mana lah. So you need to extract the aggregate lah, okay, from the parent rock. Parent rock ni dia punya batu asal. Okay, so after they blast ataupun they drill, so they will transport this crushed rock into the factory lah, then they reduce into smaller size. So, however, the strength of yang aggregate yang sudah kasih proses, okay, smaller size yang 20 mm berapa mm, dia tidak akan sama. The strength there will not the strength of yang batu asal, it will not indicate strength of the aggregate in concrete. Even though let's say you guna batu yang kuat lah, tapi in concrete actually the strength it depends on this one bonding between the cement paste and the aggregate. Even if you let's say you use very high quality aggregate kan, tapi if the bonding is not good, then the strength of concrete tu dia akan reduce juga. Okay, so the strength of parent rock does not indicate strength of the aggregate, but this it depends actually on the bonding lah between the cement paste and in the aggregate. Okay, so what does it mean lah with the bonding lah between the cement paste. So this is the cement paste with the aggregate here. So you can see kan in between dia ni bonding dia. Tapi macam ni macam licin kan. So this one is macam smooth lah. Okay, smooth aggregate. But the bonding is here. between. Kalau nanti belajar lagi detail tapi mungkin in advanced concrete technology, this layer we call it as ITZ. So ITZ is the interfacial transition zone. Tapi sini we just call it as bonding lah. Okay. Okay. So the strength of aggregate, there's ways lah to determine strength of the aggregate. Okay. One of the method to determine strength of aggregate by testing aggregate based on the aggregate crushing value. Ini nama testing aggregate crushing value. So this aggregate crushing on the how better lah the aggregate resist to crushing under compressive. Kita maksudnya masukkan aggregate in a mold, then you crush dia gitu. Okay. Kalau this one is the macam not very detail lah, tapi you can refer here the method. Okay, the size of aggregate, this is based on standard, tapi tiada pula which standard. So this one, the size of aggregate used is between 12.5 to 10 millimeter lah. Kamu save dulu lah, then you obtain between 12 to 5 and between 12.5 to 10 millimeter, and then you put in the mold. So mold tu is cylinder lah, cylindrical mold. So you put the aggregate here, okay, and then you crush the aggregate. Okay, using a compressive load. Mungkin adalah the machine kamu apply compressive load, okay, on this coarse aggregate, and then after that kamu sieve. Kita sieve dia, okay, and then you sieve using this 2.36 millimeter sieve lah. Okay, so the how to calculate material crush to finer than 2.36 millimeter. Yang maksudnya aggregate passing 2.36 millimeter, yang tu kamu timbang. Okay, so the percentage of aggregate passing 2.36 meter, you divide by dia punya original weight, cari percentage, that will give you crushing value of aggregate. Macam tu. So tengoklah kalau if the aggregate strength is good, after you crush it with apa-apalah loading, bila sieve mungkin the amount yang crush below 2.36 tu mungkin kurang. Depends on the strength. Kalau aggregate is not strong, bila kamu crush, kamu apply the loading and then you sieve it, so mungkin dia punya the aggregate passing 2.36 millimeter will be higher lah the percentage. Itu one of the way lah. Okay, so here kalau mau refer yang the last two statement sentence, the crushing value of aggregate restrict to 30%. This one is for rods and pavement. Kalau you want to use the aggregate for rods or pavement construction, kamu check the strength. If the strength less than 30%, maksudnya 30% less passing 2.36 millimeter sieve, then okay, boleh lulus for you to use for rod and rod construction. But for other structure, for building, so the limit is 45%. Should be more than 45% lah. Okay. Okay. Another test to determine the aggregate strength is the aggregate impact value. So this method lebih kurang, hampir lebih kurang lah, sama. But this one is toughness. So the aggregate toughness meaning how well the aggregate to resist failure by impact. Ni dia ada blow dia. Tadi dia crush, dia tekan sampai ikutlah berapa ton kan. But this one, you put the aggregate in a mold, the cylinder mold. For example, in mold lah, cylinder mold, and then you subject the aggregate to 15 blows using metal hammer. So dia ada metal hammer berat 14 kg. So angkat lepas until 15 times, 15 blows. So ketinggian is 38 mm lah. So let's say this is kamu punya hammer. Ini dia hammer gini lah contoh dia. So the distance is 38 centimeter. And then you release. Then angkat lagi, release until 15 blows. And then sieve balik. The same process, you sieve. Then you check how many percent of the aggregate passing 2.36 in halus sudahlah di crush. So the aggregate impact value is the ratio of fines. So this one is yang finer than 2.36 yang sudah hancur tadi. So dia punya ratio, dia maksudnya weight of fine divided by weight of total sample lah, then you express it in percentage. Kalau lagi tinggi, meaning that the aggregate strength is tidak bagus lah. Okay, and also you can test the strength using the aggregate abrasion value. Okay, so this one is actually to test more to its resistant to wear. Macam friction lah, friction. Normally if you want to use this aggregate for road, construction, warehouse, pavements, mana-mana yang ada macam bergesel lah. Kata warehouse floor, kan kamu angkat ada macam, apa tu nama dia tu, yang macam truk kecil-kecil tu angkat barang tu. So dia ada friction. So in order for you to produce a good concrete, you have to make sure that the aggregate has a good abrasion value lah. So this one kita boleh check guna Los Angeles abrasion machine. Okay, so dia ada explanation sini. Just masuk dalam abrasion machine tu and then dia pusing macam tu lah. Okay. Okay, so we finish with aggregate strength. So there are three methods lah tadi kan. Aggregate crushing value, aggregate impact value, and aggregate abrasion value lah to determine aggregate strength. Okay, next is modulus of elasticity. So modulus of elasticity, this one of course lah the properties of aggregate, not only the modulus strength, also the chemical composition and so on, actually depends on the composition, texture and structure of the aggregate lah. And this modulus of elasticity, it will influence the properties of aggregate in terms of the shrinkage, the elastic behavior and creep. So shrinkage, you know kan, concrete they can shrink. Yeah, actually the aggregate also, if it has a good elastic behavior, then in terms of shrinkage too, they're better lah to resist this problem lah in concrete. And creep, you know what is creep? Apa dia creep? Okay, so this one is more on the concrete lah kan, creep. So creep ni contoh dia deformation with time. Deformation with time, let's say, katalah this is your concrete structure kan, and then katalah ni bilik store lah, senang cakap, store. Okay, let's say you put many things lah inside your store, banyak barang, okay. Over time, let's say 1 year, 2 years, 3 years, 10 years, 20 years, what happened to the concrete floor? Sometimes it can bend, begitulah, deform lah, it can deform. Okay, so if you put all this loading, 1 day, 2 days, 1 week, 1 year, maybe you still cannot see the deformation lah. Okay, but let's say you leave it for longer time, then actually your concrete floor can creep. So creep is actually deformation with time. Dia akan deform, dia akan apa bani deflect sini. Because of the loading, that is creep. Okay, so the modulus of elasticity of this aggregate, actually it will influence lah whether the creep, your concrete creeping is good or not, low or high, macam tu. Okay. Okay, next is bulk density, or sometimes we call it as unit weight of aggregates. So okay, so this bulk density, it will give information okay, apa dia ni? Okay, it will give information regarding shape and grading of aggregate. So look here. Normally bulk density, what does it mean here? Because macam, let's say you have a macam apa, mall lah, for example mall, and then you put the aggregate inside the mall lah. Okay, if your aggregate is higher in bulk density, so meaning that kalau dia punya bulk density higher, meaning that the aggregate packing is very dense. Very dense, dia rapat, dense apa in BM? Mempat dense, lebih kurang lah macam tu. Okay, they're very dense. So the bulk density, saya letak B dia, bulk density is high. And also the void, okay, within this aggregate is less lah. Okay, is less. So meaning that the bulk density is high. Okay, so how it relate to the shape and grading. Normally, if the shape is round kan, kalau dia round, if you try to pack it in a mall, is same size of mall lah, for example. Normally kalau yang bulat ni, dia bulat macam ni kan. So the packing, the bulk density will be much lower lah. Because there are many, kalau mau tengok many pore void here. Dia ada, bukan pore void, sorry, there are many void in between the aggregate. So the cement, the sand, and cement, we need more lah to fill in this void. This is low bulk density. Okay, so that is if the shape is bulat-bulat grading, itu bulat-bulat belum grading lagi. Kalau angular, let's say this one is angular, dia nipis-nipis kan, an angular, so it can be more packed lah, dense compared to yang bulat. So the bulk density will be higher. How about grading? So grading meaning, let's say same size of aggregate, katalah 10 mm. So kamu susunlah dalam same container punya size. Okay. Compared to, susah mau lukis lah. Compared to, let's say this one is gap graded. Gap graded maksud gap graded maksud to aggregate, it consists of varying size lah, not only one size. Example here, let's say A, only one size, 10 mm saja semua, or 20 mm saja semua. But then yang B, this one, B, gap graded aggregate. So dia ada besar size of aggregate and it also has smaller size aggregate. So yang B will have high bulk density because of the grading. They are gap graded. Dia ada size besar and then it has smaller parts aggregate size. So it will fill in between the voids lah, compared to aggregate grading only one size. Itu maksudnya. Yang ini shape, yang this one is grading. Okay, so semakin dense, semakin memampat, the bulk density will be higher. Okay. Okay, absorption and moisture content. So this one is very important. Tolong bagi tumpuan for this topic, yang subtopic. Okay, absorption and moisture content. Some aggregates they are porous and absorptive, but so far almost all aggregate they are porous and absorptive. Okay. So when your aggregate, let's say this is your aggregate porous. What does it mean with porous? Porous dia ada lubang-lubang lah. Lubang-lubang kita memang tidak nampak, tapi of course dia ada lubang-lubang kecil-kecil. So when there is a pore void, your aggregate dia akan porous. Okay, so absorptive. It able to absorb apa-apalah, water ke, apa-apalah di luar ni, as long as it is in the solution form. So it can absorb. Ini kalau this is inilah porous and absorptive. Okay, nak tolong concentrate. Okay, so since aggregate they are porous, okay, and absorptive, it water cement ratio and workability. What is water cement ratio? Workability semua dah faham. What is water cement ratio? Okay, kita tengok balik. Concrete you have what? You have sand and then you have coarse aggregate. So the ratio of water to cement, this is what we call as water cement ratio. Okay, itu maksud water cement ratio lah. The ratio of water to cement lah in your concrete. Okay. And also this aggregate also it will affect durability of concrete. More example is freezing and thawing, chemically aggressive liquids. Okay, freezing and thawing because let's say your coarse aggregate tadi saya dah tunjuk dia ada pore void lah kecil-kecil, absorptive. So it can absorb water from your concrete. Okay, dia boleh absorb water from your concrete. So once it absorb water from your concrete, meaning that the aggregate itself, dalam dia halus-halus, it will contain water. So when let's say mau masuk dia dalam freezer, kalau in European countries, of course they have this winter season kan. So bila they exposed to freezing, what happen is that the water it will expand. Water dia punya, yang kita tahu ni science. Water bila dia mengeras, jadi ais, dia akan expand, mengembang. So how many? About 9%. So imagine lah, kalau dalam pore void of your aggregate kan, dia ada water and then dia ada apa, dia become ice, dia expand, mengembang. So what happened to the aggregate? Aggregate boleh pecah. Okay, so that's why they affect durability. Actually not only aggregate lah, concrete also it has pore void. The same thing will happen lah if water in the pore voids of your concrete dia become ice, dia akan expand. So kalau hardened concrete, you imagine lah, they expand, of course it will give hydrostatic pressure to the surrounding concrete area, dia cracking lah. Okay, so same to the aggressive liquid ni, macam ada silica, acylic sulfate, chloride, acid, alkali, all this actually it will affect the concrete durability lah. Okay, so therefore in proportioning the materials for concrete, nanti kita belajar mixed design, because if you want to produce concrete, let's say you want to produce concrete with 50 MPa strength. So bila kita mau produce concrete with 50 MPa strength, you still need water, you still need cement, sand and coarse aggregate. But how much? What is the proportion? Dia tidak akan sama lah dengan concrete. Let's say you want to produce concrete yang ada 20 MPa strength. Still the material is still similar, but the percentage or amount of this material, the water, cement, sand and coarse aggregate will be different. Okay. So when you proportioning the materials for concrete, you must always consider, bukan always, it is compulsory to consider this aggregate condition. Apa condition aggregate during that time? Always taken for granted. Bila you design your concrete, the best condition of aggregate is the aggregate they are in SSD condition. So SSD condition is S is saturated surface dry condition. Mungkin sudah belajar in civil engineering material lah. SSD is saturated surface dry condition, meaning that your aggregate is saturated, fully saturated with water, but the surface here is dry. So this is SSD condition. Bila your aggregate is saturated but the surface dry, dia boleh serap air ke tidak? Tolong jawab, dia boleh serap air ke tidak? Boleh serap air kah? Katalah span kamu tu dah tepu dengan air, dia akan serap air lagi kah? Tidak kan? Okay. Itu if you design your concrete, we always consider aggregates they are in SSD condition lah. Masih on ke ni? Saya dah tengok kamu ni dah dalam grup, tanta saya terlog out sudah.
Masih ada doktor.
Masih ada, masih ada. Syukur, saya ingat saya satu orang bercakap. Okay. Okay, so hopefully still until this point still understand kan. Okay, that is when you design your concrete on the paper lah, we assume that the aggregate is in SSD so that there is no absorption lah, begitu. However, besar ni, patut saya letak huruf besar ni. However, in practice, aggregate in SSD condition, in ideal condition, is very difficult to met lah, very difficult to find. Susah lah mau cari aggregate having this SSD condition. Why? Because if you refer here, aggregate, it can be in wet condition. What does it mean aggregate in wet condition? Okay, hari ni hujan. Saya rasa petang ni hujan. Okay, aggregate kita di lab, for example, or let's say you engineer lah. Aggregate you export, you just put your aggregate kan tidak ada bumbung, example lah. So hujan, sekarang ni pun kejap hujan, kejap panas kan. So when your aggregate exposed to rain, ataupun mungkin kamu cuci-cuci your aggregate, what happen is that your aggregate, it will contain surface water. Apa maksud surface water? Masih tu percakapan, saya padam dulu. Okay. What is surface water? Kalau syok waktu di kelas bah, kita boleh rendam tu aggregate and then I can show you the surface water. Tapi you can imagine lah, kan? So let's say this is your aggregate lah. If your aggregate is exposed to rain, hujan. Oh hari ni hujan. Okay, pergi lab tengok lah. batu basah sudah di luar dia ni. So the surface water here is inilah water on the surface of aggregate, coarse aggregate or fine aggregate. So that is surface water. Okay, so your aggregate is in wet condition. So when there is surface water on your aggregate, meaning that dia akan menyumbang kepada extra water. Extra water to your concrete mix. Kan, logic kan? Because when you design your concrete, you have to make sure that the water to cement ratio is fixed, constant. Dia kena constant. Let's say you design your concrete 0.5, the water cement ratio is 0.5. Let's say kalau 0.5 katalah water is 10 kg, cement is 20 kg. So the ratio of 10 to 20 is 0.5. So this water cement ratio must be fixed in your mix design lah. But when you use your mix design to produce concrete in lab lah, for example, then the aggregate used to dia basah. Kita tadi assume when you mix your concrete, we assume that the aggregate is in SSD condition. Tapi bila dia basah, ada extra water on the surface, what happen is that it will increase the water cement ratio. Harap faham lah. So ada surface moisture sini. So the surface moisture, it will contribute to the increase of the moisture here. Sini, dia kasi naik sini. So katalah you punya moisture is 10 kg. So now it's not 10 kg anymore. Mungkin dia 10.5 kg because of the surface moisture. So we don't want this to happen lah. Okay. So that is if the aggregate is subjected to hujan ataupun kamu cuci lah. Itu contoh. Okay, tiba-tiba besok pula kemarau. 1 minggu kemarau. Okay, so what happened to your aggregate kalau kemarau? So when days macam kemarau ke apa, so your aggregate will be in dry condition, exposed to sun for a long time. Okay, when your aggregate is exposed to sun for a long time, okay, kita rasa-rasa bukan rasa, memang tengok this aggregate is in dry condition. So when your aggregate is dry, what happen is that it can absorb moisture from the outside. Dia akan absorb because tadi kan kita dah bagi tahu some aggregate they are porous. Once they porous, they absorb teeth. So if your aggregate is dry, it will absorb moisture from this water yang ini and this one. Dia akan absorb, dia diserap masuk dalam. So it will affect the workability. How it affect the workability? Macam mana pula dia affect workability? Because kenapa? Cuba jawab.
So they absorb water.
Ialah they absorb water. So how they affect the workability?
Reduce water lah.
Betul. So the free water that is actually required for your cement hydration, cement reaction with this water, cement reaction with cement lah, dia sudah tidak cukup because of some of the free water already been absorbed by this dry aggregate. So susah lah, kita workability is low and also hydration also will not complete 100%. So both condition they are harmful to concrete. Jadi macam mana kita? So which type of aggregate yang kita perlu? Yang perlu adalah SSD. But in reality SSD no, very difficult to get. So macam mana? So in making concrete or good quality concrete, you have to do adjustment. Kena buat corrective measure lah. Kena check. That's why nanti next semester when you do your lab subject tu kan, next semester, before you cast your concrete, before you produce your concrete, you have to do lab work. Kamu kena design concrete dulu lah. You have to design your concrete and then you have to do your lab work in order for you to determine the absorption, the condition of your aggregate lah. Either your aggregate is in wet condition or dry condition. Macam tu. So adjustment. How? Tengoklah. You have to determine what is the absorption percentage of your aggregate. Is there any free moisture content? So free moisture content normally on the surface lah. Okay, if the free moisture content ada, maksud your aggregate is in wet condition, so you have to adjust the amount of water to cement ratio, the amount of water here. Let's say tadi kan kamu dah kira 10 kg is enough lah to produce, kata I want to produce 50 MPa. But since your water is, your aggregate is wet, kan dia tadi akan menyumbang, katalah yang wet ni dia ada 5 kg, bila timbang-timbang, nak timbang-timbang lah kita boleh kira the total amount of free moisture, let's say 5 kg. So kalau kamu, 0.5 terlalu banyak. Okay. Kalau kamu tidak buat adjustment, what happen is that the water instead of 10 dia jadi 10.5 kg. So dia sudah kacau tu ratio. Adjustment is by, kamu kena tolak lah, 10 minus 0.5, the free water 10 minus 0.5. So dia ada, kamu kena timbang 9.5 kg free water, and then yang 0.5 ni daripada batu tadi, wet cost aggregate, dia akan tambah di sini lah automatic. So dia akan sama dengan 10 kg juga. Itu what does it mean lah with water adjustment. Same to dry lah. If your aggregate is dry, let's say dia dry lah, dry, it will absorb water from this 10 kg. So let's say you do lab testing lah, and then you know that the absorption is about kata 2%. So 2%, you have to calculate how many water is required to make sure that the aggregate is fully absorbed. So nanti 2% ni tambah di sini. Katalah berapa lah, 2% lah berapa, then kamu kena timbang air 10 plus yang 2% ni. So dia ada extra water, but that extra water actually to tackle the absorption. Ini nanti kita akan detail in mixed design lah. Kita akan belajar in detail, bagi contoh dan bagi soalan juga ni, soalan favorite ni dalam test dan juga dalam exam. Okay, this one is the aggregate condition. So basically dia apa condition lah. Okay, mungkin in reference book ada yang 3, ada yang 5. Okay, so in general 4 condition. So the first one is the oven dry. Maksudnya the pore void also empty, there is no moisture. The second one is the air dry. So air dry, the pore void is partially filled with water lah. Dia ada air juga. Okay, and then saturated surface dry. Saturated surface dry meaning that all the pore voids already filled with water. They saturated, but there is no moisture on the surface. Itu SSD ya, SSD, saturated surface dry. And the last one is wet. Kalau wet ni, not only the pore void they fill in with water, but the surface also they contain water. So that is categorized as wet. So these are 4 conditions that you must understand lah. Okay. Okay, so we finish with the aggregate condition and absorption and moisture content. Please baca lagi lah untuk fahamkan yang ni. Okay, so we go to the bucking of aggregates. Siapa mau pergi toilet bolehlah pergi ya. Saya teruskan sekejap. Okay, bucking of, what is bucking? Okay, what is bucking? So bucking is because of there is a free moisture content in the aggregate lah, on the aggregate. Okay, so it will cause bucking. Let's say your aggregate lah. Let's say this is dry ya. This is dry aggregate. Bila kamu pack dry aggregate in a, katalah in a container, gitu kan? Dia, you see that the aggregate actually it will be in contact with each other. Dia kena lah rapat-rapat because it is dry. However, if your aggregate is wet, okay, kalau your batu kamu basah atau pasir basah, the free moisture content it will form a film around the particles of your aggregate. Ni kamu punya aggregate kan, so dia basah. Okay, dia basah, so it will form layer of water film around your aggregate particles. So let's say I have the same volume of container, tapi ini dry, ini kata dry ya. Ini, and then let's say the volume of aggregate here is 10 kg. 10 kg. So this one also 10 kg ya, 10 kg of aggregate lah. But the aggregate here dry, this one is wet. Okay, so wet aggregate, kalau kamu tengok dia ada water film di atas, water film di atas, water film on the surface lah. Okay, so dia begitu, dia begitu, dia begitu, dia begitu, dia begitu. To fill in the same 10 kg amount of coarse aggregate in the same mole, actually dia tidak sama dengan dry. Why? Dia akan terlebih ni, dia akan terlebih. Dia bucking, dia increase in volume. So increase in volume because of the formation of this moisture film around the aggregate. So dia akan menolak. Okay, so this water film with satu lagi coarse aggregate or fine aggregate having water film also, it will keeps away lah. There is no point of contact between this particle. So the volume increase. This increase in volume, that is what we call as bucking. Hopefully faham lah. Okay, kalau dry, no problem. So there is no bucking. But if it contain moisture, so dia akan menolak-nolak. Macam dia ada extra lapisan lah. So suppose 10 kg muat di sini, kan? But because of bucking, dia tidak muat dalam container ni. The increase in volume. Okay, so that is what it mean by bucking. Okay, so bucking of this one is example of sand, bucking of sand. So dia increase in volume, dia macam bukan sand tu mengembang, but increase in volume because dia ada extra water film around the particles lah. Okay, if you see here, actually bucking of the aggregate, it depends also on size. Okay, ini dia tunjuk on for sand lah. Okay, we have coarse sand, we have medium sand, and we have fine sand. So if you see here, the coarse sand, okay, yang the Y scale, that one is increased in volume lah, in percentage. So if you refer to this graph, you can see that the coarse sand, the bucking of the coarse sand, they are always lower than the fine sand. Sebab fine sand, dia punya size very fine kan, so dia ada bagi banyak particles. So if it become wet, so dia punya increase in volume is high compared to the coarse sand. Coarse ni dia kasar. Itulah dia efek, biasanya dipengaruhi juga oleh size of aggregate lah. Okay, sand or coarse aggregate. Okay. Okay, next is deleterious substance. What is deleterious substance? So this one actually apa-apa materials or impurities, kotoran on the aggregates. Your aggregate kan, when you use in our case concreting lah kan. So the aggregate dia tidak semestinya bersih. Okay, it can contain deleterious substance. The category here you can see impurities. So impurities, it can interfere with the hydration process. So when it interfere with the hydration process, so the strength development is not good lah. Dia kacau tu hydration. Okay. And then nanti kita tengok lagi detail coating. Sometimes your coarse aggregate tidak bersih, so dia ada coating. For example, like let's say the aggregate dia ada clay, tanah liat. Kamu dikorek-korek dari sungai, tidak cuci, and then dia terus guna in construction. So there is a clay coating on the surface, so it will prevent from good bonding. Kita dah belajar tadi kan, good bonding will increase the strength. So if there is interference in the bonding or reduce the bonding performance, of course the concrete strength also will be affected. And the last one is weak particles or unsound. So this one is they refer more on the aggregate itself lah. Some of the aggregate is not strong aggregate lah. They're weak. Mungkin dia ada siput-siput, kulit siput, especially when you use mungkin batu ke atau sand from mungkin dredging from the seaside. Kita tengok one by one. Okay, so this one apa ni? Impurities. Okay, so impurities, it can be organic impurities. So organic impurities here, example is decay of vegetable matter, tumbuh-tumbuhan lah. So it will, for example, like humus, okay, is organic loam. So this is example of impurities lah. So it can present in sand. Okay, so in order for you to use it in concrete, before you use it in concrete, you have to make sure wash it first lah. Okay, it can be removed by washing. So kena cuci dulu lah. Okay, and then you can test whether your aggregates is clean. You can use this colorimetric test. Okay, and then clay and other fine materials. So clay semua tahu tanah liat. So it can exist, present in the aggregates in the form of coating lah. They coat the surface, so it will interfere bonding between the aggregate and cement paste. Silt and crushed dust. This one also just dalam bentuk surface coating, okay, or it not only surface coating but also it can exist or present in the form of loose material. So meaning that they mix together with the aggregate lah. Okay, kalau let's say you use sand, bila sieve let's say sand nanti later on when you go to lab lah kan next semester bila you sieve, kalau dia passing 75 micrometer that one is considered as dust. So itu yang kacau kita punya mix lalu lah, because it will increase the water requirement. This one increase the water requirement. Okay, so kena check lah. So this example of impurity. So tengok kotor, so cuci. Okay, you wash the aggregate, you can remove the impurity. Okay, and also salt contamination. Sometimes normally the sand lah. Okay, normally long time ago also normally bukan dulu-dulu lah. Construction of the building construction kan dorang guna tu apa pasir laut. If they use the sand from the seashore, it will give problem later on lah. Maybe not now, but after 10, after 20 years, nanti kamu tengok lah tu dia akan pecah-pecah. Okay, because of the corrosion. Okay, so let's say you don't have any choice lah. Maybe katalah dalam you punya project construction, tiada choice lagi. Itu saja lah ada pasir laut. So what you can do is you can wash lah the pasir laut because you want to reduce the amount of chloride. Then kamu buat trial mix. So if dia punya strength is still acceptable within the range, then you can use lah. Tapi if possible, don't use sea sand lah. Okay. This one, corrosion of steel, and also it will cause efflorescence. So efflorescence is white deposit on the surface of your structure. Sometimes kan kita menyandar di dinding tu tunggu kelas. Bila kita gerak tengok putih dah belakang kita. Itu one example of the efflorescence lah, white deposit on the surface of the wall, concrete, because of this chemical. Salt, because of this salt lah. Okay. Okay, this is example lah. This one example of efflorescent, macam chloride, sulfate. Bila you let's say you use sea sand, so dia ada chloride. So later on bila dia water evaporate, so it will bring together this chloride, this sulfate. Okay, but dia tidak akan evaporate. It will stay on the surface of your concrete or your building surfaces lah. So itu yang nampak white deposit. We call this one as efflorescent. Okay, corrosion semua tahu lah. Okay. Okay, so next is soundness. So we have two types of unsound aggregate. Soundness ni two types of sound aggregate. Sound aggregate meaning aggregate is good lah. Dia kukuh lah, keras. Unsound meaning that yang dia terbalik lah. Okay. So there are two types aggregate that fail to maintain integrity. They fail to maintain integrity because of these impurities. The second one, when the aggregate is exposed to, for example, freezing, thawing, exposed to water, tapi lama-lama dia hancur. That is also considered as unsound lah. The example of unsound aggregate here, you can see lah the shell, coal. That's why bila you check aggregate, make sure there is no shell or coal lah in your aggregate source. Okay, because it will affect your concrete. Dia kacau because it is impurities. Also not impurities but they consider not good lah. Okay, it will affect your punya concrete strength. Kena check. Okay, so soundness only one slide. Okay, and then we proceed with grading, but I believe also grading semua dah tahu. Okay, so how to determine grading? We can use the sieve analysis lah. Okay, so why grading is important? Saya dah explain tadi, because it will affect, number one is it will affect the durability. Number two, it will affect strength. How it affect the workability? Okay, because we know that grading, macam saya beritahu, if one size of aggregate, okay, grading the single size of aggregate compared to the yang gap graded aggregate kan. So this one will give lower workability, this one will give high workability. However, in terms of strength, the gap graded aggregate will, this one this one is the blue workability. So this one is the workability, but the strength will goes down. Dia macam tu. Okay, even though single size of aggregate is good in terms of workability, but in terms of strength is not good because there are many void in between. Bukan void, there are many void in between the aggregates. So this gap graded aggregate, okay, of course, because dia ada size besar, size kecil-kecil, so it when you put it in all this gap grading aggregate, it will fill in void within the aggregate yang large size. Okay, but in terms of workability, it is low workability because yalah dia ada fine size kan. But in terms of strength, it is very good lah because less amount of void. Okay, so this workability here affected by the aggregate surface area. So the aggregate surface area, if the aggregate is smooth, rough, or we already discussed, volume of aggregate, macam mana the effect, okay, amount of smaller materials, okay, kalau macam amount of smaller materials, if the smaller materials high, the workability will use guna logic lah. Okay, this one actually no need to memorize, tapi you need to understand. If you once you understand actually apa soalan saya bagi pun saya kelentong kamu, pusing-pusing pun kamu boleh jawab. Okay, and then the last one, to high strength requires a maximum compaction. So maximum compaction, because compaction we need to remove the pore void lah. Okay, maximum compaction, compaction, the purpose we want to remove the pore void. So kalau how it relate to grading, sebab kalau if the grading is macam single grading, there are many pore void kan in between, there are many void lah in between kan. So even if you compact, there is still void. But if the grading is good, I mean gap graded aggregate, the compaction you can achieve a maximum lah. You can reduce the void within the concrete. Okay, but make sure that the concrete is workable. Kalau dia tidak workable, point lah. Okay, kalau tak faham nanti boleh tanya lah. Okay, okay. Ini saya rasa extra slide mungkin. Okay, aggregate in concrete mix. Okay, kita tengok, saya bagi number lah. 1, 2, 3, 4, 5. So you can see the condition. Number 5 is just right. So the amount of aggregate, the coarse aggregate, the fine aggregate, the amount is just right. So it will give you this type of concrete. So the workability is also good because this one kan, the workability they measure using this is slump test. So this is the workability lah, they based on the slump of the concrete. Kalau kamu tengok number 1, okay, number 1, deficient fine sand. Deficient fine sand maksud there are many coarse aggregate but the amount of sand dia kurang. So what happen is that, boleh saya zoom ya? Tidak boleh zoom. Okay, what happen is that you can see that the mix is harsh. Dia macam nampak batu je lah, batu and water. Kurang simen, kurang pasir. Okay, so the workability, the texture is not very good. Okay, if you see number 2, this one is too much sand pula, too much fine. Kadang soalan saya cakap increase fines. Increase fines maksudnya we increase the amount of yang size kecil-kecil, sand or cement macam tu. Okay, so the number 2, excessive fine. So you can see the texture of the concrete is good, but then the workability is not very good lah. Sebab bila too much fine sand, dia punya specific surface area increase, so kita kena banyak air untuk kasih wet the surface of the fine kan. So kata dia punya air is constant, tidak berbeza, katalah kita ambil, saya suka ambil contoh 10 kg. So kamu tengoklah, let's say the amount of water here is fixed to 10 kg ya. Okay, number 1 tu dia kurang pasir. Bila kurang pasir, you can see that workability dia tinggi lah, tapi mixture is not very good. Number 2, dia excessive, dia too much fine, too much sand. So you can see that air yang sama, dia workability is not good, even though the texture is tempat cantik sikit lah. Okay, number 3, high intermediate. So katalah in between in your concrete mix kan, dia ada fine, the other cost, but the other medium size. So the medium size here is high lah compared to the cost, compared to the fine. So what you can see is like this one. Okay, the texture for me, the texture dia macam okay, but then dia punya the workability is not very good lah. They still considered as low workability. Okay, high cost. This one is the number 4. The cost aggregate is too much. So what happened is that of course it will increase the workability lah. Because the cost aggregate, the size is, the specific surface area is low kan, so when you increase lagi banyakkan dia, so the amount of water 10 kg dia akan ni lah, but in terms of the concrete texture is not very good also. So just right yang number 5 tu. That's why to produce just right is actually you need to know how to do the mixed design lah. Okay. Okay, and then ni nak lagi detail lah. This one deficient sand, kurang pasir. Okay, so you can see the size of, boleh nampak tu aggregate, tapi tidak cantik. Okay, this one too much pasir, terlebih pasir. Pasir je macam batu hilang. Okay, pun tidak bagus. Excessive intermediate, dia ada batu, nampak macam ada batu kecil-kecil tapi not very kecil. Dia ada intermediate lah di tengah, so nampak kasar-kasar sikit. Okay, so this one excessive coarse aggregate, yang just right yang macam ni. Dia cement, dia mix, blend well lah with the coarse aggregate and the fines content. Okay, untuk dapatkan ni, kita tahu mix design. And I think this is the last one, hopefully. Okay, so segregation. So what is segregation? So segregation is the separation of the materials that we use in concrete because of their density. Senang lah, pemisahan bahan-bahan dalam konkrit disebabkan oleh perbezaan ketumpatan, perbezaan berat lah, senang cakap. Okay, so in this example, I'm not sure lah, this one di mana dia, maybe dia tuang mungkin ni. Okay, tapi kalau kita lukis the segregation, okay, because of different in the weight of materials used in concrete production, normally the aggregate, the coarse aggregate will sink at the bottom lah, okay, followed by the sand, okay, and then cement, and then the last one is water. So this is what we call as segregation, separation because of different in weight or in density. So segregation is not good. Sometimes bila kamu compact your concrete, katalah you vibrate concrete in your mall, terlampau lama lah, kita mungkin vibrate 1 to 2 minutes lah, depends on the size kan. Tapi kamu compact lama betul, what happen is that yang berat akan turun bawah lah, yang ringan akan naik atas. So dia boleh menyebabkan segregation. Or during placing your concrete, katalah tuang concrete dalam dalam kolom. Okay, bila tuang concrete dalam kolom, kata kolom tu dia punya tinggi is 10 meter contoh. So tuang dari atas without proper precaution, kamu tuang je direct. So bila dia terhentak ke bawah, that happen is that yang coarse aggregate akan ada di bawah and then followed by yang lain-lain lah. So bila you demol your formwork, nampak tidak lawak lah. Okay, so for this case normally kita panggil honeycomb. This is salah satu juga deterioration in concrete. So dia akan lower the concrete strength. Okay, so you have to be careful lah with all this. Okay, ada lagi. So we finish our lecture lah. Saya rasa kita tak payah sambung lah kan. We finish. Ada yang mau sambung? So, ada setengah jam lagi ni. Mana sudah kamu ni? Sini. Ataupun macam mana yang lain? Boleh sambung lagi ni. But we already finish with the aggregate lecture. Kalau sambung, saya akan continue with the admixture. Untuk yang lain ni senyap yang masih ada ke depan komputer ni. Ada, okay. Mungkin take 5 dulu, saya sambung sikit saja. Sebab kita ni banyak betul iklan lah kan. Kita cuti lah, apalah. Apa dia? Semua pun di rumah. Boleh. Semua di rumah juga kan. Okay. Bukan di rumah, semua di asrama.
Yeah,
Ada problem air kah? Saya dengar ada yang tiada.
tidak
Tidak?
tidak ada problem, dokter.
Oh, sebab ada yang request sebab ada problem air. Apa? So hopefully next week kita boleh face to face lah kan. Face to face senang sikit. Senang tunjuk kamu tu sampel-sampel. Actually saya sudah collect sampel for admixture ni paling sesuai. Next topic yang saya discuss kejap lagi on admixture lah. Sekejap sajalah kita discuss. Maybe one type of we will look for one type of admixture sahaja. Okay. Kita 338 gitulah kita start. So admixture, what it is admixture. Okay, so in this section, you're going to learn about the different types of admixture. So there are many types. So here you can see the water reducing admixture. We have retarding admixture, accelerating, superplasticizer, and so on lah. Okay, pozolans also is considered as admixture lah. Okay, pozolan ni kita dah bincang last week. So what is actually admixture? Apa dia admixture? So admixture is actually materials. So the materials that we can use in concrete production lah. Okay, so their punya definition is material other than water, aggregate, and cement. Okay, which might be added to the concrete before or during mixing. So this is the definition of admixture. So katalah in test or exam, I ask you what is the admixture, you have to include all these three elements lah. Okay, material other than water, aggregate, cement added to concrete before or during mixing. Full mark. Okay, so that is admixture. So basically there are two types of admixture. Okay, one is chemical admixture. Okay, the other one is mineral admixture. Both type of admixture, they are capable of giving or improving the physical and economical benefit with respect to the concrete lah. So admixture ni actually will improve lah. Kalau ada admixture yang kasih reduce properties tu, kita takkan guna lah in concrete ni. Normally it will improve concrete properties. Okay, though these admixture they are expensive, but admixture also economically beneficial in these following ways. Number one, you can see here the admixture can reduce cost of labor, okay, because good workability concrete can make the concreting work easier. Okay, let's say you need 6 worker to do the concreting work, but because you use admixture, the workability is good. So instead of 6 worker, so you only need 4 man crew. Okay, so only 4 workers lah for the concreting work. So you reduce the amount of labor, the cost of labor. Instead of 6, only 4. So this is example. Okay, and also if you add admixture to concrete, they can reduce the cement content. We know that cement is mahal kan? So when we use the admixture, so you can reduce the cement content because this admixture it able to give strength to concrete. So no need to add more cement. Okay, to get the required strength. You just use admixture. Tapi tengoklah what type of admixture. And then admixture also improve durability without without the use of extra measures lah. So that are the main benefit lah of using admixture. Okay, the cost reduction, the labor cost reduction, reduce the cement content, and also improve durability. Okay. Okay, as I mentioned before, the admixture they are categorized into two: the chemical and mineral admixture. So for the first type we will look is the chemical admixture. So for chemical admixture, the most common type used in construction they are accelerating admixture, retarding admixture, entraining admixture, and also water reducing admixture lah. Sometimes ini water reducing admixture dong sebut as super plasticizer. Okay, itu yang normal kita guna in ready mix, in concreting punya ni lah. Okay, and then there are also various types of admixture under the special category such as grouting admixture, eddy training admixture, gas forming admixture, corrosion admixture, and so on lah. Okay, shrinkage reducing admixture, bonding admixture, and so on. Dia ada banyak jenis. Okay. So, okay. Meanwhile, for the mineral admixture, okay, so they are also known as supplementary cementitious material or SCM. Mineral admixture or SCM dia sama lah. Okay. So, SCM or mineral admixture, it is a type of material which able to give cementitious properties. When we use it, able to give, dia boleh harden. Senang cakap, dia boleh mengeras lah. But you must use it together with the potent cement, okay, because of the hydraulic and pozzolanic reactivity. Saya pernah dulu waktu saya belajar ambil master lah, because I didn't use fly ash, tapi saya confuse fly ash with cement. Color hampir sama. So saya terguna tu Portland cement lah. Okay, 100% fly ash saya guna. The next day, when I demol the concrete kan, bila saya angkat pecah. Pecah, heran lah. Biasanya normally when we cast concrete kan, you use Portland cement, dia akan harden after 24 hours. So bila check, tengok balik, rupanya saya silap guna fly ash, not cement. So itu salah satu yang saya ingat sampai sekarang, meaning that fly ash tu actually one type of admixture yang categorized as SCM ni lah, or mineral admixture. So it still require for any types of pozzolan, SCM, mineral admixture, you still need cement. It still needs cement lah to give cementitious properties. If 100% used to replace Portland cement, cannot, and dia tidak akan mengeras. Okay, that's why we call it as supplementary cementitious materials. So you can see here the type of mineral admixture, they are normally in the form of waste material, bahan-bahan buangan tu, such as silica fuel, fly ash, and so on. Fly ash last week kita discuss, fly ash is from the burning of this coal kan, arang batu. Kalau GGBS also, that one is also categorized as mineral admixture. That one is because of from the steel manufacturing process. Normally it is a waste material lah. Okay. 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 So this SCM, supplementary cementitious material, they are based on two of reaction. If Portland cement, only one reaction, hydraulic reaction lah, hydration, cement plus water. But for SCM, there are types of reaction. When you add this SCM with cement and water, there are two types of reaction will occur Number one is the hydraulic reaction, where this reaction is the hydration lah, cement plus water. Actually, this is hydration. And then pozzolanic reaction. So pozzolanic reaction is the reaction of this SCM. They react with the calcium hydroxide. So this calcium hydroxide actually it is from the cement lah. Dia kena ada. Okay, so this SCM plus cement calcium reaction mesti ada air lah. Then it will give cementitious properties. Ini kena ingat. Okay, there are two types of reaction, the hydration and also the pozzolanic reaction. Okay, for the mineral admixture also can be in different classes. Tapi kan saya pernah baca lah, there are some issues lah, classes of mineral lah. Sometimes ada yang cakap not updated lah. Okay, tapi apa-apalah. Okay, so in general the mineral admixture they can be classified either as class N, class F or class C. So class N, this one is referred to raw or calcine pozzolan. So pozzolan ni sama lah, dia ni yang SCM lah, SCM ataupun mineral admixture. So any types of raw or calcine meaning that dia kena bakar lah. Pozzolan consider as class N. For class F is type of fly ash which is produced from the burning of bituminous coal. And class C also fly ash produced from the burning lignite coal. So these are the classification of the mineral admixture lah. Okay. Okay, and then the function of admixture, there are too many. Just now I show you only 3, but actually there are many depending on the purpose lah. Okay, some of the function highlighted in this slide, such as to accelerate the initial set of concrete. So how? By speed up the rate of concrete develop at the early edges. So kalau mahukan konkret cepat keras, you use admixture. So what type? Itu nanti kita akan tengok lah. But it can accelerate the initial setting of your concrete. Okay. Instead of accelerating the setting of your concrete, admixture also can be used to retard the initial set of concrete. So dia berlawan. One is to accelerate, mempercepatkan. The second one is to retard, to slow down lah the initial setting of your concrete. Okay, for example, let's say you want to keep the concrete workable for a longer time before you press your concrete during construction, then you can add with the retarder lah, retarder. Okay, katalah kamu tiada sudah paling dekat pun tu ready mix concrete is 1 hour lah, contoh 1 hour 2 hours lah from dia punya kamu punya side project dengan tu ready mix. So tiada choice sudah, okay kena order. Tapi di dalam 45 minit dia mengeras lah, okay then the ready mix they have to consider this problem. They can use the retarder lah to slow down the initial setting. So by the time to ready mix datang to your project punya construction site, they still in workable condition. Okay. Okay, and then to enhance workability also can lah, the super plasticizer is the one good example lah that normally yang biasa guna lah in construction nowadays. Okay. So because when you add more water to your concrete, it will reduce the strength. So we cannot add water lah. Okay, so what you can do is you can add with the admixture, for example the super plasticizer. So it will improve the workability. Okay, and then what else? To improve the penetration or flowability and pumpability of concrete. So this is important for easier placing, especially if the method of concrete you use is concrete pump. Dia actually nanti kita belajar there are many types of transporting concrete lah from the your casting area to the project site. One method is by using the concrete pump. Dia pakai pump. But if the workability is not good, so macam mana mau pump concrete tu? Dia tersangkut dalam tu pump. Okay, so for pump concrete, the flowability must be good. So you can use admixture lah to improve the flowability. Okay, and also to reduce segregation. We just now kan dah tengok segregation. So you can see here, this is the honeycombing. Honeycombing. Ni kita tidak mau ni in construction. Tak mau ni. Okay. So because of segregation. So actually we can reduce the segregation by using also this admixture lah. And then to increase durability of concrete, for example, resistant to special condition of exposure, like concrete exposed to soil that containing sulfate, seawater, and so on. Kalau sulfate, you can use sulfate resisting Portland cement, but instead of using the SRPC, sulfate resisting Portland cement, you also can use this mineral admixture lah to increase the durability. Okay, and this one to prevent the corrosion lah in the reinforcement in the concrete. Okay, so there are many lah. You can see here: increase workability, decrease the capillary flow, to reduce the heat of hydration, to increase the bond. Apa lagi? To control the alkali aggregate reactions. I already explained about this alkali aggregate reaction. So this one actually can be prevented using the admixture. To increase resistance to chemical attack, to enhance bonding of concrete to the steel, to produce non-skid wearing surface, to produce cellular concrete. This one I try to produce lah, cellular concrete. One of the finalist student, saya try, kita akan study on this lah, okay, cellular concrete this semester. To produce colored concrete or mortar, apalagi to reduce weight of concrete, and also to produce concrete with fungicidal, insecticidal properties lah. Okay, ada juga ke fungi ialah kulat? Ada ke serangga makan konkrit? Okay. Okay, again. So, okay, if you want, if you want to improve the compressive strength, okay, this one is admixture. Sorry, this is admixture for durability. If you want to use admixture for durability, for example, like frost action, but in Malaysia we don't have this frost action problem, so we can use the air entraining agent lah. Okay, usually for frost attack, this air entraining agent, it can help to resist the damage by providing bubbles. Bila kamu tambah air entraining agents, concrete tu dia akan ada bubble, but minute bubbles, very small bubbles. So this one we will discuss in detail belakang nanti lah. Okay, but you know the entering agent can be used in frost action problem. Okay, and then if sulfate acidic attack, where the mineral admixture that you can use like pozzolan and polymer emulsion. Okay, what else? Alkali aggregate expansion, also you can use pozzolan. Okay, then for thermal strength, where you can choose pozzolan as the admixture juga lah. Usually this one for large mass concrete construction. So if you still remember, last time we discussed about the low heat Portland cement, the application in the large mass concrete construction. So instead of LHPC, you also can use this pozzolan lah. Okay. Apa lagi ni? Okay, and if you want to improve the compressive strength of concrete, you also can use admixture such as the water reducing agent. Ini yang super plasticizer. When you use the water reducing agent, actually you improve the workability lah. And also you can use pozzolan. Okay, so water reducing agent admixture. Okay, we used to reduce the water content while maintaining the consistency. So I think that's all lah for today, because this one is on the mineral admixture. The second one is the chemical admixture. So for the chemical admixture ni, dia punya subtopic lagi banyak sikit lah. So this one we will discuss in the next lecture. Okay, I think okay lah. Sekarang pun ada 4 minutes lagi before we end our lecture. So yang lain okay ah? So we continue next week for chemical admixture. But before that, I would like to share the apa nama dia ni? The attendance. Okay, in the chat box. Okay, so the attendance link is shared in the chat box. So tolong mark your attendance before you left the class. So kalau ada apa-apa soalan sambil-sambil boleh tanya.
Doktor, chat tak dapat buka.
Dah boleh buka?
Ya.
Saya share dalam grup lah, okey kah? Dalam grup lah.
Okey, doktor.
Okay, so saya sudah share dalam grup. So hopefully semua attend lah kan? Okay, so those yang sudah mark attendance, you can leave the lecture room.
Thank you,
Kalau ada
Doctor.
soalan, sama kalau ada
Thank you,
soalan
Doctor.
tanya, boleh